how do I know my helium antenna and cable is still okay? Keep it simple, keep it real, know your physics. Now this is probably a topic that's more personal, and I just play with this stuff all the time, and I thought, well, hang on, rather than me just playing with this and studying what's going on, maybe I should just share what I'm playing with. And the spreadsheet that I'm going to refer to, I'll put on our website as well. There's a link underneath the video for that spreadsheet. It's not a professional endorsed setup, and there's more questions that I'm actually going to raise here that I still want to get answers for. I've actually done this video first in February. This is now end of April, and then I stumbled upon a little issue that I still need to get my head around. And now I thought, you know what, let's just get this out there and get some feedback potentially, and people say, well, actually, yeah, that's true, or maybe there's an explanation for that. But I'll get to that now. So first of all, how do you know that your system is okay comparing to others? And we get it as RF shop. We get a lot of people that say, my antenna is not giving me enough rewards or earnings. I need a better antenna. Is it really, or is it just the network that is doing some funny stuff? Because we know, at the moment it's before the light hotspots are coming on board, and then things have been up and down a little bit for the last few months actually, or by now. But you can still analyze your system, and you can still see if your antenna and your cable is okay. Plus, what you see today is okay. You want to see again in a few months' time, is it still okay? Or if you have remote systems running in the middle of nowhere, it's really important, because you can actually use Helium Explorer to just keep an eye on things and make sure that your cable is still okay and things are not going funny. So what do? I would go to your miner, or the miner that you want to look at, the one that's in question. You would go on the Helium Explorer and go to when it sent a beacon. I would look for the beacon that had 14 witnesses, because that's just giving you the most data that you can actually use. So go to an instance in the last whatever, I don't know, I looked this morning, and I actually had to look 6 days back before the last time I had a proper beacon sent. But that doesn't matter. It's all about physics now. Don't worry about the detail. So you take an instance where your miner, or the miner you want to look at, has sent a beacon and that had 14 witnesses. There you go. I just have on the screen just an example of what you get. So what you would see there is you see distance, you see RSSI, and you get signal to noise, SNR. You get those 3 values, and you get that value 14 times. So I created a little spreadsheet. The spreadsheet, as I say, is there, and there's the table. So all the cells in yellow, you can populate with those numbers. So you just go one by one and fill those numbers in. So you would say distance. You don't have to go in order. You don't have to go from the nearest to the farthest, because that doesn't really make a difference. It's all relative. You can see in this case, the examples I had there was 8.6 kilometers. These are all kilometers. I don't know if it shows differently in different countries, miles or something. I don't know, because I'm in Australia, where we use the kilometer system as well. But anyway, these calculations are all based on the metric system. So distance is 8.6, 3.4, and they go down the list. I select the frequency down, 915. Much of a muchness, but if you're in Europe, you probably want to change that to 868 so that the calculations match your network, because that's a big enough change that it would affect. Populate the RSSI table just for each one. So go the distance, RSSI, and the signal to noise number. What it gives you then is what the ideal path loss would be. Now, there's always a debate with some lecturers that I work with often, that if you say path loss, you're already saying it's a negative. So the number there is a positive. It's kind of semantics with positives and negatives. So the path loss is 110 dB, but you would say it's minus 110 dB, whatever, or lower. But I hope you understand what I get. That it's just the path loss number is positive, because you're already saying it's a loss. And then I just like to look at noise floor. Now, I've had people say, well, that's not useful and stuff. I said, okay, that's fine. But rather than just looking at signal to noise, which could be anything and it doesn't tell you much, if you look at the noise floor, which is the RSSI minus the signal to noise, because just think about this. A signal exists, there's noise somewhere. Signal to noise means the peak of your signal relative to the noise. So that number gives you that distance, but that doesn't give you enough. So by looking at what's the floor here, I just want to see this. So that's the baseline that I have. And the noise floor is between you and any link. And it's just to look relative to all the other ones, if it's similar or not. So I'll show it now what it gets. So basically that table, a bit too much information there, and tables are terrible because it doesn't give you anything. You look at the numbers like, well, I don't know, it doesn't make sense to me at all. I'm going to get back to this slide, but I just want to show what I actually see when I look at it visually. In the spreadsheet, I then take the numbers, RSSI and distance, and I put it on a plot. Now this is where it gets interesting, and this is actually what's useful. You just put those numbers on a plot. Now what the orange number is the theoretical expected path loss for that distance at the frequency. So that's kind of the curve that you expect to see. The blue ones is just the measured results that you get. And that's still a bit confusing, I agree. But in Excel, of course, there's the beautiful feature of just putting in an exponential fitting. So you just tell Excel, okay, give me a trend line as well. And the trend line is actually closely matching what you would get, but you always have your outliers. And now what's interesting is the outliers, because that's where you want to look at what's going on. There's two outliers that I thought I'll just highlight here, because they are obviously, first of all, skewing my plot. You could see it actually gets close, and that's because there's an outlier right in the first one, which is the closest to me in this specific test case. It's much higher than the other ones. I don't know why, I can't explain why, but there's something. I might want to reach out to this gentleman. I might want to figure out what's going on. And then the next one, that's the one at the bottom. It's very low. So the signal is, for the distance that this person is from me, the signal is very low. Something is weird. That's just how you check the health. You can see, well, what's going on here. And actually, if you see the outliers and you can reach out to that person and see what's going on. It doesn't help you, though, because you don't know what's happening here. So what you would do is you would take one of your witnesses and just return the favor. So basically go to one of the guys that you witnessed, and then you, rather than looking from your perspective towards the outside, look at his perspective towards his outside, and you will be one of those dots. If you are the outlier and you test other ones and you keep being the outlier, then there's something wrong with your setup, and you have to get back to your setup and see, well, what's going on. So if it's you looking at the other ones, you see who else, is there anyone that just has a weaker signal or a stronger signal than you expect to see. If you look at other ones, you may see yourself, and if your signal actually makes mathematical sense in terms of the distance from one guy to the other or not. Now, the other thing here is basically this wouldn't, the curve shouldn't change over time. I mean, you get minus coming in, going out, that kind of stuff happens. Physics will never change. So you will see the physics, the trend line needs to stay the same. That the guy is X distance from you, you should always see the same kind of response. Now, I know, no, actually it doesn't. Antenna differences, some would have 3 dB, some would have 6, some would have 9 dB antennas. However, if they do the right thing and they adjust the numbers in their hotspot setup, in general, it evens out, and you shouldn't see that difference there. This is now getting a bit hairy, because this is the issue. I actually assume 0 dB transmission, and this is why I got myself caught up in February. There's actually 30 dB missing, or there's actually 30 dB more than I expect to see. And I always assumed, and I still assume, that I transmit here in Australia at 30 dBm. If I do that, my free space path loss does not work. I actually am 30 dB stronger. Well, no, my miners are measuring 30 dB below what I actually want to see. It's a puzzle I still can't solve, and that's why I didn't have this video out there for 2.5 months now. But I thought, well, I might just put it out there as well for comments, and anybody could maybe tell me what's going on. But I've had so many checks, so many questions about the path loss. So I just go for 0 and 0. So you at least see the curve in the trend line, and you can see the outliers. So the trend line needs to follow the same curve. It will be offset. The offset is something that's still a bit of an uncertainty to me, but the trend line itself, the behavior needs to be exactly the same, because from your distance to the other guy has to be a predictable number, because physics does not change. Now the noise picture, which is pretty much just, I dumped the noise floor on there as well, and you'll see at the bottom there is just common noise floor roughly between 110 and 100 and about around 100 and minus 115 dBm. That seems to be the noise floor is for these IoT gateways and the system and the surroundings. Here in Adelaide, it could be a different picture completely if you have a quite densely populated city like Sydney, Melbourne or San Francisco, those cities. I don't know, I haven't done that study. Again, Helium Explorer is free to look for anybody, so you could just have a play. What I do note though is that there's one that has a much higher noise floor. So again, that's the guy that had the very strong signal. Something between me and him is weird, and we need to look at that. And that's just how I could see this by looking at Helium Explorer doing a study per beacon. And that's just what I play with, and I thought, let me just share this because it gives you some insight into what the health of yours is. I'm just going back to my first slide with the table, because this is kind of just the mental note of why I'm doing this. The first one here is know your environment, because this becomes your identity. You'll see, and you can just study that things are going all right as far as your hotspot is concerned. Study the noise floor. That's a personal approach. So I like to see that floor line, because the floor should be the same. If somebody has a higher noise or lower noise, there's something that should be done to make it different. As I said, physics does not change, so the physics will always be the same. They can come with new POC rules, can come with other ideas. The physics of the radio link between you and the other radio should be the same. That's a test wire beacons. That's what I explained. Can test yourself and others. Yes, I explained that as well. I mean, we're all in this together, so help yourself and others to get the best overall network. If you see somebody has a problem and they may not be aware of that, because you don't do the study, you just look for witnesses, this is a way to kind of help your community and reach out to somebody. You say, well, there's something that's just not as intended, or there might be something we can do together to make it better for everyone. And then for yourself, this is now, of course, Helium is quite new in Australia. It's already a few years old in the US and in Europe. You are likely to get some issues over time. So corrosion, you hope you don't get corrosion, but 5 years is a long time, and corrosion might start to happen. Your antenna might move because of a storm or a big wind incident. And then, of course, vegetation and construction is going to happen. So trees might grow, and suddenly there's a tree in the way that you didn't take note of, and that could cause some trouble in certain areas. Having this constant study, constant as it once every 6 months or something, will show you stuff. And then construction, there might be a few neighbors coming on and they all have double-story houses and you have a single-story house. You're not paying attention because it's after 6 months you just have your miner running. If you do the study, you might suddenly see something changed. I didn't realize I need to take care of this. This is kind of the kind of thing that will help you just move through that. As I said, I hope this is not a pointless video, because this is a trick that I do. I'll put the spreadsheet on our website, and I actually want to open up this discussion about where is that 30 dB that I'm missing going. Are we really transmitting at 30 dBm, or are we transmitting at 0 dBm? Interesting question. Let's have a look. See you again soon. Cheers, bye-bye.